Now, let us define the distance of a point from origin. So, what is the distance between a point to origin? So, in two-dimensional geometry, suppose if it is x-axis, y-axis and origin, and P is a point whose coordinates are x comma y. Now, the distance from origin to that point is, this point is at x units distance from y-axis, so that it is x units, and y units distance from x-axis, so that it is y units. So, here a rectangle is formed, so that this length is same as to this length, so that if it is x units, it will be x units. So, now right angle triangle is formed here, and OP will be the hypotenuse. So, by the Pythagoras theorem, the OP square is equal to x square plus y square, and OP is equal to root over x square plus y square. Now, the distance of a point P x comma y from origin is root of x square plus y square. It is in two-dimensional geometry. Now, we are going to find the distance of a point from origin. Consider a three-dimensional space, x-axis, y-axis, z-axis and origin. Suppose if P is a point whose coordinates are x, y, z. Okay. Now, how to get the distance from origin to that point? OP. For this, we just consider a cuboid first. It's a cuboid. Now, there are three mutually perpendicular edges. This is, and here I am taking this edge as x-axis and this one as y-axis, and this is z-axis, and the intersection of these three axes is origin. Now, let us take the point P whose coordinates are x, y, z. Now, let us take one point. Now, this vertex is on x-axis, let it be A. This vertex is on y-axis, let it be B. And let it be C, D, E, F and G. Okay. Now, see, now we are going to find the distance from O to P. Here, a right angle triangle is formed here. See, O, P, D. From this diagram, O, P, D. The triangle OPD is a right angle triangle. Right angle triangle. Hence, from this right angle triangle, OP square is equal to OD square plus DP square. But OD square can be taken as, see, OAD is also a right angle triangle. It is also a right angle triangle. In cuboid, this edge and this one are perpendicular. So that OAD is also a right angle triangle. Hence, OD square can be taken as OA square plus AD square plus DP square, since the triangle O A D is right angled. Now OA square is equal to, what is OA square? What is OA? What is AD and what is DP? Now see, OA, AD and DP are the three distances of the point P from the different coordinate planes XY, YZ, ZX. OA is equals to, here let us take some point. This point is G H. Now OA is equal to HP. OA is equal to HP in cuboid. But what is H? H is the point in YZ plane. Now the point P is at a distance of x units from YZ plane. So that HP is equal to OA, that is equal to x. So that it will be x square. Next, AD. AD is equal to EP. AD is equal to EP. What is EP? It is the distance of the point P from XZ plane. So that AD is equal to EP, that is equal to y, hence it is y square. And DP. DP is equal to, DP is directly, D is the foot of the perpendicular from P to the XY plane. So that directly DP is equal to Z, hence DP square is equal to Z square. Therefore, OP square is equal to x square plus y square plus z square. This implies OP is equal to root of x square plus y square plus z square. So the distance of a point from origin is root of x square plus y square plus z square. Now, let us define the distance between 2 points. Before that, in two-dimensional geometry, it is x-axis, this is y-axis and origin. Suppose origin is shifted to some point h comma k, and here P is a point whose coordinates are originally x comma y. When this regular coordinate system is moved to shifted to h comma k, it is a new axis known as x dash and it is y dash and this will be o dash. Now the new coordinates of P will be, x minus h comma y minus k. So earlier you studied the shifting of origin to some point. Right now, coming to the point. Distance between the 2 points. Now in three-dimensional geometry, x-axis, y-axis, z-axis and it is origin. Suppose if one point A whose coordinates are x1, y1, z1 and second point B coordinates are x2, y2, z2. Suppose if this origin is shifted to A, now the new system will be like this. When origin is shifted to this point, then the new coordinates of B become, these coordinates become x2 minus x1, y2 minus y1, comma z2 minus z1. Now these are the new coordinates of P when origin is shifted to A. So now origin is shifted to here, let it be O dash. Now the distance of AB, is equal to the distance between O dash and B. Of course, let it be some B dash. Now, the distance from O dash to B is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Therefore, the distance between the 2 points in three-dimensional geometry is given by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now, the direction cosines of a line. Let us take three coordinate axes again, x-axis, y-axis, z-axis, and suppose if a line is this one, L is equal to 0. Okay. Now, direction cosines of this line L is equal to 0. Suppose the line L, which makes an angle alpha with the x-axis and beta with the y-axis and gamma with the z-axis, then cos alpha, cos beta, cos gamma is called direction cosines, simply DCs of the line L is equal to 0. So, direction cosines means the cosine angles alpha, beta, gamma. What are alpha, beta, gammas? Alpha is the angle made by the line with the x-axis and beta is the same line making angle with y-axis and gamma is angle made by the line with z-axis. Then cos alpha, cos beta, cos gamma is called direction cosines. Now, these proportionative values of direction cosines of a line are called direction ratios. For example, some lambda into cos alpha, lambda into cos beta, lambda into cos gamma, where lambda is some scalar but not equals to 0. Then lambda cos alpha, lambda cos beta, lambda cos gamma is called direction ratios, DRs of the same line L is equal to 0. Now, these are the two important definitions, direction cosines and direction ratios. Now, generally the direction cosines of a line are denoted by LMN. LMN or the DCs of a line L. Therefore, L is equal to cos alpha and M is equal to cos beta and N is equal to cos gamma. Now, suppose if I consider the line L is equal to 0 like this. Now, we can take a line which is parallel to L is equal to 0 and passing through origin. So, consider a line which is parallel to L is equal to 0. Let it be some L dash is equal to 0. Now, if the line L makes an angle alpha with the x-axis, then L dash is also making the same angle alpha with the x-axis. Why? Because these two are parallel lines. Now, here this length is equal to, suppose if the length of some point P is a point P is on the line L dash is equal to 0. Now, from this diagram, cos alpha is equal to this length, of course it is nothing but x coordinate by OP. Similarly, cos beta is equal to y by OP and cos gamma is equal to z by OP. If this line makes a beta angle with y-axis, then you could get another right angle triangle with respect to y-axis. From that, cos beta is equal to y by OP. Similarly, from with respect to z-axis, cos gamma is equal to z by OP. But generally, the direction cosines are represented by LMN. Therefore, it is L, this is M and it is N. Now, squaring and adding all these three quantities, L square plus M square plus N square is equal to, what happens? L square is equal to x square by OP square, M square y square by OP square, and N square is equal to Z square by OP square. See here, denominator is common, that is OP square, and numerator is x square plus y square plus z square. This is x square plus y square plus z square by OP square. What is OP square? It is the distance of the point from origin. Of course, here the point P whose coordinates are x, y, z, and this is the line L dash. Okay, P is a point on L dash and whose coordinates are x, y, z. Then L square plus M square plus N square is equal to x square plus y square plus z square by x square plus y square plus z square. Here both gets cancelled and it is equals to 1. So that finally we can conclude that L square plus M square plus N square is equal to 1. That implies, but what is L? It is none other than cos alpha. Therefore, cos square alpha plus cos square beta plus cos square gamma is equal to 1. So, sum of the squares of direction cosines of a line is always equals to 1.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.